welcome again. So in week 9, as I mentioned in the previous video, we have Excel file for sampling distribution of sample mean. But we didn't work on this topic during week 9 because we had to do a number of things that we were supposed to cover before and they came up. So we moved this to week 10. So if you can go to week 10, so we started looking at the sampling distribution and estimations. So we have sampling distribution and also we have confidence interval, which is the estimation. This should read confidence interval. We have a video for sampling distribution and also we have another video for confidence interval that was posted. But we are going to make another video which will provide more information about sampling distribution of sample means and also confidence interval. And then from there, we are going to have another video which will be on the hypothesis testing and then regression analysis. That's the last topic we're working on. So in this topic, we have a theorem which we call central limiting theorem. And it's one of the most important theories in statistics. And this theory or theorem talks about having a number of samples of a certain size that will be taken from the population with mean and standard deviation. Sometimes we may not have mean and standard deviation of that population, or a mean of that population may not be provided, but the standard deviation will be provided, as we're going to see in the hypothesis testing. So we are talking about having samples of a certain size that are taken from the big data or from the population. So in that case, we may have a number of samples. So let's say we have sample 1, and then this may be of a certain size. Let's say 30. 30 is actually better or more. So the sample size should not be less than 30. They should be at least 30. So we may have data which we can get from the population, and then we can create the sample. We get the first sample, and then we can select another sample, which we can call it sample 2. We can also get another data, which we'll call sample 3, and so forth. Someone write etc there, meaning that we can get a number of samples from this population. And in this case, we are talking about the population with average and standard deviation. So this collection of sample means forms a probability distribution called the sampling distribution of the sample mean. Now, each sample, we can find average, and we can also find standard deviation. So here we can get average, and also we can find standard deviation of each sample. So let me pull this to the side. So each one will give us average, and each one will give us standard deviation. And so I just leave this space showing that we have sample data, and they should be greater than 30. They start from 30 and more. So we'll find average and standard deviation of each. Now, if we can find average, and sometimes we can call it grand average, and this average will be the average of these averages of the samples. So that means we're going to take the average of the first sample plus average of the second sample plus average of the third sample and so forth, divide by their total. That will be the grand average. So it will be the average of the averages of the samples that we have. Now this average, which will be obtained for these averages, it's assumed to be the same as average of that population. So the more samples you can take and find the averages of those samples, find the averages of each sample. Then find the average of those averages, meaning that you're going to add them and divide by their total. You're going to get average, which will be the same or will be more or less the same as the average of the population. So this information is important because it can help us to come up with an average, which we can assume that that average is more or less, or it's close to the standard deviation of a population with some allowed margins of error. So that's what we said here, the mean of the distribution of the sample means. Remember, mean is also an average. So the sample means equals to the mean of the population. That's what we have said. Now, what about standard deviation? The standard deviation of the sample means. So we're going to look at the standard deviation of the sample means, or we call averages. And the standard deviation of this equals to the standard deviation of the population. And so the standard deviation of the population, as I said, it's known. Divide by the square root of the sample size. And in this case, we call it standard error. So let me write here. This is, in other words, the standard error. So if we can find standard deviation, let's say we have standard deviation of the population, and that will be divided by the square root of the square root of the sample size. It will be the standard deviation of the sample averages. So that's the second, or I'll say, important information about this. The distribution of the sample means follows normal distribution if one of the following conditions is met. So we are assuming that these sample means are normally distributed if we are obtaining them from the population which is normal, regardless of the sample size, or the sample size should be greater than 30. Those are the conditions for this central limiting theorem. So in week 10, we tried to work on a certain example to see how we could select the samples from the big data. And we worked on the ABC data. And so let me open that particular file and show you how did we select the samples. So the ABC file has this kind of data, and this one is posted I think in week 9. And so we can open another Excel file or worksheet, and let's say sample selection. So call it sample selection, and all we need is to get this data, just the salary data, and we're going to copy it, and then we're going to paste it in this new worksheet. And then we will need to find the average and also standard deviation. And so average, we just put equal sign and type average, and just click from this column. And so we have average. And to get standard deviation, just type standard deviation, as we've been working on this many times. And so just find the standard deviation of that variable, which is salary. And so that is the standard deviation of the whole data. Let's find it, the sample size. So let's find it, that's n. And so in this case, I think, let's find it, put count. And so we're going to count. So we have 46 as our size. Now assume that this is a big file, big sample data, which is not 46, but it is more than 46. And let's select a number of samples from this file to see if we take all the file, if we find averages of those samples, and we find the average of the averages of the samples, and compare with this average to see if it's going to be the same or if it's going to be closer to this average. So here, we're going to find the first sample and call it sample 1. Let's create a number of samples. Let's create about 5 of them. And we are not going to follow the requirements that says the sample size should be greater than 30, but I'm going to show you how you could select sample, or you can select data or your sample data from this big data. So one approach for this is we should select values randomly. And in this case, let me create column here. Let me insert column. So to find data for the for this sample, let's say we want to take each sample should contain 10 values. So we're going to randomize this data and select just 10 values. So let's call it run. We're going to randomize our values, and so just put equal sign and type rand, and then close the bracket. Open the bracket and close the bracket and enter. So you can see, let me put 2 decimal points. So you can see we have 0.25. Let me make more. So if we randomize this section here, we're going to have 0.2567. That's just a random number, which is not associated with all this, but it's just randomizing a value. So in this case, let's try to randomize values which are equivalent to the values that we have. And therefore, I'm going to double click here. And so we have random values that correspond the salaries. So you can see that these values always change, and because we just randomize some values, and they will always change. So just leave them as they are. And in this case, we have created some random values, and our intention is to organize them in an, let's say, ascending order or descending order, so that we can select values that will be organized according to how we're going to organize our random values. So I'm going to click in this column, and let's go to the sort, and let's select custom sort. And in this case, we're going to expand selection, which will go to salary and employees. And so I'm going to select sort. And I want to sort these values by random, by the rand, which is column C. So column C is actually the random, or the variable there is random. You can see now your data may not be like this. I mean, information which you can get from your sort may give you just the names. Sorry, let me cancel this. I know what happened. So I'm going to repeat again. So we're going to sort, we're going to organize these random variables from ascending or descending order, and they will include these other variables. So let me select the variables, and would you go to sort and filter, and just select custom sort. So in this case, we're going to sort by rand variable. Sort by rand variable. In other words, we're going to organize random values in relation to these other variables. So in this case, we're going to select from the smallest to the largest. So if you click OK, you can see that we have the smallest to the largest based on the salary and the number of the employee. So you can see the first one to be selected is 39 all through. And in this case, we need only 10 of this. So let me copy, and I will paste for the first sample. So then all I'm going to do is I'm going to sort again, and that will be random sort. And so I'm going to select these values again, and so I'm going to do custom sort, and then I'll do exactly the same, and the order is the same. So I'm going to click OK, and you can see we have different sets of data. And in this case, I will also select 10 values. In this case, let me just select this data, copy and paste. That's for sample 2. Let me do again to get another sample. So in this case, I'm going to go to the sort and custom sort and do exactly the same, and then I'm going to click sort, and you can see that we have actually different values as well. And so I'm going to copy and paste. So I'll do for the 4th sample and 5th sample, or more samples. But all we're going to look for are the means or averages. And in this case, just put equal sign and type average. Select these values. And so when you enter, you will get average for the first sample. I'm going to click here to differentiate this with the values. So to get the sample for the second one, because they are organized in the same fashion, So we can actually drag this to the left, to the right, and we have averages for the first sample, second, third, fourth, and so forth. So the next thing you're going to do here, after selecting this number of, after getting the averages, so we can find grand average, or the average of those averages. So what we're going to do here is just put equal sign and then do the summation of these averages, close the bracket, and just enter. So that is the sum, and let me copy this, copy and paste it here. So this will be sum of the averages. So we sum all of them, and to get grand average we need to divide by their total. So I'm going to put equal sign here, click this one, and divide by their total, which is 1, 2, 3. So if you type 3 there, in fact we have grand average. So we have the average of these averages. And what the theorem or central limiting theorem states is that this average will be the same, is considered to be the same as the average of the whole population. So let me highlight this. Now, if you look at this average, the question is this the same as that average? We can say it is not. So it's a little different from this average.